Okay, let's understand how the least square works. Okay, so least square is a measure to finding out better approximate straight line. If we talked about the linear least square, linear regression. Okay, so in the case of linear regression, so means that we are approximating some set of points. So let's come to this diagram. Okay, suppose we have these points are there, say some bivariate points are there, and here pointer, let's say, so here this is your first point. Okay, so this is the coordinated, so this first point coordinate is x1 y1, right, and next point is x2, so this is the x2 and corresponding is y2, right, and similarly this is the x3 y3 and this is x4 y4 and so on. Suppose there is some up to, let's say, xn points are there, and first we are plotting this x and y end point in the xy axis. So here different x end points and their different y end points are there, and corresponding their uh, point exact location is showing in this diagram. Okay, now let's see that we are approximating all these points by a line. This is the line, and corresponding this line we are approximating these defined points. Okay, so let's, the equation of this line is y equal to a plus bx. Okay. We are thinking that this is any line, and where a and b, these are two unknown, a and b are two unknown, and we have to find out a and b, so that these point straight line is approximating these defined point uh, very close to this straight line. Okay, so we have to estimate the best a and b, so that this will be more or less closer to all these point. Okay, so error of this approximating by this straight line of this all this point, error will be least. Okay, so that's why it's called the least square. Now if I approximating this point, all this point by this straight line, so first point, let's say x1 y1, this is the first point, so here is that corresponding point, and if we approximating by this straight line, then the corresponding point in this case it will be here, right, if I approximating. So your new y1 will be this one, but your actual y1 is here. But if you use this straight line, then you will when you put x1 here, right, then you will get new y1, that is the approximating of y1 by so it will be, the value will be a plus bx1 when you put x equal to x1. So new value that will be here, that is your new point here, that is the approximating point of this y1 by this straight line, and the location of this point is here, that is x1 and a plus b1. So this point is a plus bx1, and here this is the y1. So these will be error. So this is your error if we approximate by the straight line. So if I denote this corresponding this length, that is e1, that is the error of approximating this x1 y1 point by the straight line, then your error will be y1, this one, minus a plus bx1, right. So first error e1 will be y1 minus a plus bx1. Okay, now similarly for the next point, that is x2 y2, so your x2 y2 point is here, and if you approximate this x2 point by this using this straight line y plus a bx, then your corresponding approximate point will be here. So and that here your point value of this point will be a plus b x2, right. So it will, this point value will be a plus b x2. Okay, so in this case your error will be this one, that is y2 minus a plus bx2, y2 minus a plus bx2, right. And similarly last point xn, you will get the error is here, that is up to xn, suppose xn point is here, and this is the xn yn, so error is, this is the error, and that is, let's say, en. Okay, so en will be yn, that is the yn point, and minus a plus bxn. So this is the error of if we approximating all the defined point by the straight line y equal to a plus bx. Okay. Now I don't know what is, I have to find out the best a plus bx so that error will be minimum. Now if I sum up all the errors here, if I take the sum of all the error, then this error is positive sign, where this is the negative. Similarly this is positive error, right? Because this is that here y3, if I talked about this is y3, so y3 will be more than the approximate value somewhere here, that will be a plus bx2. Similarly here the error will be negative. Okay, so if I sum up this all this one, so sometimes the error might be cancel out, so error might seem 0. So that is not the best way. So one thing another you can do is that you take the absolute value here, take the absolute value e1, absolute value here. Similarly take the absolute value of this one, and en absolute value, take the absolute value all this point. Okay, that you can do. But in that statistics we take the um, square error. Okay, so that's why it is called the least square. So instead of taking the absolute value, what we will take, basically I will take the square of this term, I will take the square, e1 square I will take that square. Okay, and e2, similarly e2 square I will take. So this is no longer a absolute, so this is the bracket, then e2 square, and similarly last point I will take the en square. So here will be our en square. So our total error, then I can sum up all this one, and now it will not be cancel out because all are now positive. So our total error e, that will be that one, e1 square, e2 square, and en square. Now e1 is this one, right? Now if I take that square, then it will be minus a minus b x1, similarly so on. Now there was y1 minus a bx1 plus y2 minus a bx2 up to yn minus a b of xn, that square. Now these all the terms I can write in the sum from this way. Sum is sum over I ym yi minus a minus bxi. Now here a and b I have to estimate in the best way such that this error is the least, error will be least. So what I can do there, so here given this is the function, I have to choose a and b in such a way that error will be least. So in this case I use that this formula, you know that for finding out the maximum or minimum value of this one, so I have to minimize this one, so minimize e, I have to minimize this e. So to find out the minimum or maximum value of this e, I have to take the partial derivative. So here are two points are there, arbitrary points are there, a and b, that is the arbitrary, whereas x, I, y are all are known, right? So I have to find out the best a and b. So what I will do here, I will take the partial derivative of e, so it is d delta e by delta a. Now if I take this partial derivative here, this should be equal to 0. So this is the first condition, that to find out the maximum minimum, so here we will take the minimum. So first condition is that del e by del a, that should be equal to 0. This is the first condition. Next one will be del e by del b. So next one should be del e by del b should be 0. So this is the first two conditions required. Now if I take the partial derivative of this function, okay, so here we have sum over I equal to 1 to n. Now here yi xi is no longer a variable, so this is a constant because I know what is xi yi. Now here variable is a and b. Now first I partial derivative, so yi is constant, and so here is square is there, so first square 2 will come in the first, right? Then they are to the power 1. Okay, now after that we will take the partial derivative inside this one. So partial derivative for yi with respect to a, that is 0, and partial derivative of negative of a with respect to a, that will be negative, so that's why negative comes here. Now last one, the partial derivative of this term, that is also 0 because this is also with respect to a, partial derivative a, this will be 0. So only negative 1 will be there. So this is the partial derivative, and that should be equal to 0. That is the condition. Now minus 2 I can take out from outside of this sum, and I can divide this one minus 2 both sides. So I will have only sum over yi minus a minus bxi, yi minus a minus bxi equal to 0. That is the first equation I got. I write down, this is the number 1 equation. Similarly, by equating del E by del B equal to 0, I will partial derivative here. Okay. Now similarly here sum over 2 square, that 2 will come here, then yi minus a minus bxi to the power 2 minus 1, so that is 1. After that partial derivative inside this term. So then partial derivative with respect to b, this is 0, this is also 0 with respect to b, and here with respect to b it will be minus xi minus. So minus is here and xi is there. So as the sum is over I, so xi is there inside the sum, and minus 2, as this is a constant, I can take out and neglect this one minus 2. So only sum over this term will be there. Now if I multiply xi with the bracket, then I will get xi yi minus a xi minus b xi square, that is equal to 0, right. So I write this is the equation number 2. So first equation I got by doing the partial derivative del E by del A equals to 0, and from that I will get the sum of yi minus a bxi, that is equal to 0, and from the next equation, that is del E by del B equal to 0, I will get this equation, sum over I xi yi minus a bxi minus bxi square equals to 0. That is the number 2 equation. Now I have two equation 1 and 2, and I have two unknown a and b, right. So I can find out what is the a and b. So here we will use another technique to solve this problem, not by eliminating a and b, but other technique I can find out a and b. Okay, so how? So let's solve these two equation 1 and 2. Now what I will do here, I will take the sum for the first equation. I will take the sum in the first equation. Let's say I will take the sum in the first equation, so I will get separate out all the terms. So first term, that is sum over yi, that will come here. Now in the second term, sum over a, and a is a constant. When I will take the sum is basically over I, so in that case a is constant. Now n number of points are there, so sum of n times of a, so that will be basically a times of n. Now next one, here also b will be regarded constant because sum is over I, so it will be minus b sum over I xi. Okay. Now next step, what I will do, I will divide this one by n. I will divide all this term by n both sides. Then I will get, this is sum over yi by n minus a, and n will cancel out, so minus a, and minus b sum over xi by n. Okay. Now sum over yi by n, that is basically arithmetic mean or mean of y, that is y bar. Now last point, that is here, that is sum over xi minus by n, xi by n, that is the mean of x, that is x bar. So what I'll see here, that so if you remember that I have first taken that approximating straight line as y equal to a plus bx, right. So first we have considered this is the our approximating straight line. Now if I see in this equation 3, if I write see that equation 3, this one, then I see that x bar and y bar, that is the mean of x and y variable. This x bar y bar basically satisfy this straight line. So right, so you see that if I write y minus, if I take this a plus bx this side, so it will be y minus a minus b of x, right, that is equals to 0. Now if I take the y bar x bar, then I'll see that x bar y bar basically satisfy this straight line, right? So it is satisfied by this equation 3. I can say that mean of x and y satisfy the given straight line y equal to a plus bx. So it means that the straight line we have basically worked here in this here, this is basically there is some point is somewhere here where your x bar y bar is there, because it lies on the straight line x bar y bar lies on this straight line y equal to a plus bx, because it satisfies this given equation y equal to a plus bx. So I know if I go back again here, so I know here that x bar y bar is a point in the given straight line. Now if I find out what is the slope of the straight line, then I easily can find out what is the equation of the straight line. So our main purpose is to find out the best straight line. So I know what is the point here, any point that is the one point in the straight line, that is x bar y bar. Now if I know what is the slope of this straight line, so slope of the straight line is b, right? Now if we find out what is the b here, then I can write down the equation of this straight line, that is our y minus y bar, right, equals to b into, so b into x bar, that will be our equation of the straight line, right? Because I already know that x bar y bar, that is the mean of x and y, lies on the straight line. Okay, so now I'll find out only b, then I find out what is the straight line, equation of the straight line. Now come back here, equation 3 update. So here we'll see that mean satisfy this straight line here. So mean lies on the straight line y equal to a. Now what we will do, we will find out b, that is our purpose. Now from the equation, from equation 1 I will got this one. Now we will start with equation 2. Now go back, what was the equation 2 here? Equation 2 was sum over xi yi minus a xi minus b xi square. So here if I take sum separately, then I will get sum over xi yi negative of sum over a xi, then minus sum over b of xi square. Now a and b with respect to I, that is constant, so that will be come outside the bracket. So sum over xi yi minus a sum over xi minus b sum over xi square, that is equal to 0. Now I will divide both sides by divide by n. So I will now divide this is by n minus a, and sum over xi by n, that will be x bar, minus b sum over xi square by n. Okay, so I'll get two equations 3 and 4, where I now my goal is to find out what is the value of b, because if I know what is the value of b, then if I put in this equation, because I know x bar y bar lies in the straight line. Now if I put the value of b, then I get the equation of the straight line. Okay, now I eliminate from this equation 3 and 4, I eliminate a, then only b will be there, then I can find out the b value. So to eliminate a, if I multiply this first equation by x bar, so I multiplying the first equation, this third equation by x bar, then I will get this one x bar y bar minus x bar a minus b x bar square, right? Now after that, if I take the difference between this and this, this a will be cancelled. So equation 3 is giving this one, and equation 4 is giving this one. Now I am multiplying this equation by x bar, so I am getting x bar y bar minus a x bar minus b x bar square equals to 0. Now I will take the difference between these two, so this will be negative, this is negative, so it will be positive, so this is, and here it will be positive, right? I am taking the difference between these two one, so I will get this one minus of x bar y bar, and these two will be cancelled out, and minus of b x this one minus x bar square, because this is the positive, so negative and negative, that will be positive. Now from this equation I can find out b. If I take b on the right hand side. So if I take the b on the right hand side, so it will be there, right? Then b will be sum over xi yi by n minus x bar y bar divided by this term. Okay, so b of so what is this term? So this is basically, if you see, this is basically your variance of x. So sigma x square, that is the variance of x. So b of sigma x square, so this term is the variance of x. So that is denoted by sigma x square. Sigma is the standard deviation, and if I take the square of the standard deviation, that is the variance. So b sigma x square, that is equal to this term. So b sigma x square is sum of xi yi by n minus x bar y bar. Now I am taking the n both sides. I am just calculating n, finding out the denominator and numerator in a single way, single digit. So here it will be multiplied over here, so n x bar y bar by n, and this the numerator term. I can write this one by this way: x bar minus xi minus x bar minus, so it will be yi minus y bar. Okay, why? Because if you take the sum here, if you multiply these two terms, then your first term will be xi yi, then the next term will be negative of xi y bar, then your term will be negative of x bar yi, right? Then plus of x bar y bar. Okay, then you will see that one n x bar will be cancelled out, x bar y bar is constant. Okay, and yi and xi is variable, then one n xi will be cancelled out, then you will get this equation. Now if you see this term, this is the numerator term, and you will see this is basically comes in the correlation thing. If you divide this one by n sigma x sigma y, then this will be correlation between the x and y, and as the sigma x sigma y is not there, so I am adjusting this one by multiplying again sigma x sigma y. So this term is basically r, that is the correlation between the x and y, and that is multiplied with sigma x sigma y. Okay, so b will be then divide, so sigma x will be cancelled out both sides, so one sigma x will be here, so that will be divided by here, so it will be r sigma y, and one sigma x will be cancelled out, so divided by one sigma x will be there. Now I know what is b. Now as I told that I can write down now the equation of the straight line, that is the your regression line here, that is y minus y bar, that is the point, and this is the b I now know. So this is the equation of the regression line. We can find out by equation by using the least square. Okay, thank you.